Hi guys, welcome back to shabest online tutorial. In today's tutorial, we're going to learn how to verify that a given function satisfies the Rolle's theorem. If you are new here, consider subscribing to my channel and also follow me on Facebook, TikTok, Instagram at shabest online tutorial. The question on the board reads, verify the Rolle's theorem for the function f of x is equal to x to the power of 4, where x is an element of closed interval minus 2, 2. So let's get started. Solution. For a given function to satisfy the Rolle's theorem, the following condition must satisfy. Condition number 1. For all x is an element of what? Closed interval a, b must what? Must be continuous. Continuous. And the second condition is for all x is an element of open interval a, b must be differentiable. Then the condition number 3 is what? F of A must be equal to what? F of B. Then the last condition, there exists C. C is an element of what? Open interval A, B, such that what? Such that F at first derivative of C is equal to what? Is equal to 0. So if this four condition is satisfied, then we can conclude that the function is satisfying Rolle's theorem. So from this we must C is equal to x. If this condition satisfy the Rolle's theorem, then we are going to conclude that the given function satisfy the Rolle's theorem. So let us start from condition number 1. We say for all x is an element of closed interval a, b is continuous, where a, b imply what? Minus 2, 2, where a is minus 2 and b is positive 2. So x to the power of 4 is a continuous function, and also any polynomial function is differentiable. So x to the power of 4 is a polynomial at degree 4 is also a differentiable. Now let us look at f of a, and f of a implies f of minus 2 because a is the same as minus 2. What is implied that from the function f of x is equal to x to the power 4. Now to get f of minus 2 is the same as anywhere we see x, we are going to substitute minus 2. We're going to have minus 2 to the power of 4. And if you substitute minus 2 to the power of 4, it's going to give us what? Positive 16. Because a negative number raised to the power of even number, the result is going to be positive number. You may press calculator minus 2 to the power of 4, it may give you minus 16, but the correct answer is 16. Now let us look at f of b, and f of b is the same as what? F of 2. And f of 2, if you substitute 2 to this function, we're going to have f of 2 is equal to the function is x to the power of 2, which is the same as 2 to the power of 4, which is also the same as 16. Therefore, this function is continuous and is differentiable. And also the number 3 condition, f of a is equal to f of 2, f of b. So if you look at f of a is 16, then f of b is also 16. Therefore, the number 3 condition also satisfy. So let us see there exists C is an element of open interval a, b such that what? F prime of C is equal to 0. Now, we're going to have f at first derivative of x is equal to, we're going to differentiate this function once. If you differentiate x to the power of 4, it's going to give us 4x to the power of 3 using power rule. Then f prime of c is equal to 0 and f prime of x equal to 4x. So to get f prime of c is equal to 0, and recall that from this c is equal to x. So this is the same as f prime of c, which is what we're going to have 4x to the power of 3. But recall that c is the same as x. So we're going to change this x to c, which is equal to 0. Now to look for the value of c, we are going to divide both sides by the coefficient of c, which is 4. 4 will cancel 4. C to power 3 now is equal to 0 divided by 4 is 0. Now to get c, we are going to take the cube root of both sides. If you take cube root of c cube, is going to give us c, which is equal to cube root of 0 is equal to 0. Therefore, the value of c is equal to 0. And we notice that this interval is what? Minus 2 less than c, and c is less than positive 2. And this 0 on the number line is between -2 and 2, is in the interval -2 and 2. You can find 0 in between these two intervals. So this is how to verify that the given function satisfies the Rolle's theorem. Thanks for watching, and please don't forget to subscribe to my YouTube channel. Also follow me on Facebook, TikTok, Instagram at shabest online tutorial. Thanks.